wants to move in more way.
All right, let's start with number 8. It tells the equivalent resistance of the circuit, and then ask us to find one of the circuits. Pretty doable. So for this one, I would have done just a diagram. So I'm going to start with their diagram. I don't feel like redrawing it. This is what do we say, number 8?
Yes. Yes.
Number 8. And so when I'm looking for equivalent resistance, I'm trying to reduce the circuit down to a single resistor. I can only combine resistors that are actually in a relationship with each other. So I could combine the 75 and R, right? Because they're in parallel to each other. They're not related to the 24 though. So I'm going to call this R7R. And this is still 24 ohms. And then I can combine those two, because now they're in series with each other. I'm going to call that R, better R, hold on, R total. We're going to start with some valid physics equations. No, that says R7R. Because it's a combination of, yes I will, it's a combination of the 75 ohm resistor and the R resistor, which I don't know yet. Alright, so there are my valid physics equations to start, and I've got to work backwards. So to go, because I know what our total is, right? Our total is 42 ohms for me. I read it out of my problem. So I've got to work backwards. To go from the bottom step up, that's a series move, and to go from this middle step up, that's a parallel move. So for series, I'm going to say 42 ohms equals 24 ohms plus whatever R7R is. Right? Can't go any further than that. I'm going to make you happy. We're not going to call it R7R. We're going to call it Bob. That's just Bob.
So we don't do anything.
Yep, Bob's just the value of that virtual resistor. Bob's just Bob. And then I'm going to look at that transition that took me from the first circuit to the second one. And that was a parallel one, so I'm going to have 1 over Bob equals 1 over 75 plus 1 over R. Oh, I know Bob, don't I? I should move all this down. Oops. Bob is just, 18. I did subtraction.
Oh, 24 minus, 42 minus 24?
Yep. And so rather than Bob here, I've got 18. And I am trusting that you guys can mathematically. Alright, so 16. They ask us to find the equivalent resistance of this circuit. So, remember, one of the keys here is you can only combine things that are actually related to each other. So I would, of course, do my normal equations from my equation sheet. I don't want to give up that point. Which resistors are actually related to each other right now?
R1 and 2.
R1 and 2 are related to each other, and they're in parallel.
R3, 4, 5.
And R3, 4, 5 are related to each other, and they're in
Parallel.
parallel. But nothing is related to R6. And 3, 4, 5 right now individually, like 3 is not related to 2 or to 6. Right? That does count once we redo it. So, I don't know, can you guys handle two things at once? Maybe? So I'm going to say that this is the combination of 1 and 2. So I'm going to call it R12. And then, oops, I got to redraw that because that was horrible. And then this is a combination of 3, 4, and 5. And this comes here. And this is still just R6. So now I've got R3, 4, 5, and R6 that are in series to each other.
Yeah.
So leave that guy alone. Combine R3, 4, 5, and R6. So 3, 4, 5, 6.
Now they're parallel?
And now those two are in parallel.
Oh, snap.
So now I get down to a single resistor. That's all of them, R1 through 6.
Add them all up.
So, no? Nope, because I need, for R3, 4, and 5 to combine to be R3, 4, 5, I'm going to use parallel, right? Because they're in parallel. So 1 over R3, 4, 5 equals 1 over R3 plus 1 over R4 plus 1 over R5. That's this step, right?
Yeah.
And then and also in that step, this side of it, it's 1 over R12 equals 1 over R1 plus 1 over R2. Remember, I did 2 at once there.
It says like R1, 2, is that you multiply them? Or add?
That's Bob.
Yeah, that's awesome.
I got to switch colors. And to go to here, out with series, so R3, 4, 5, 6 equals R3, 4, 5 plus R6. And then to go from here to here was parallel. 1 over R1 through 6 equals 1 over R12 plus 1 over R. Oops. My R's are getting worse as the day goes on. 3, 4, 5, 6. Yep, that would do it. And this is when you start making friends with your reciprocal key on your keyboard. Because
So you could add those?
the x to the minus 1. I mean, 1 over Numbers are easy to do if you use the x to the minus 1 case. You could actually bring these together into one huge equation. That'd be kind of interesting. So that was what, 16?